Okay. How about now, please? Are you able to get me? Can you just confirm now you are able to get me in terms of sound? Let me see if you are able to get me now. You said there was no sound at first. Are you able to get me now? Is there a sound? Okay, someone is saying yes. Okay, so which means I'll re-explain the first part that I was explaining while you were saying there was no sound. Okay, so what I was explaining is that here we have the question that is true. Pure breeding dwarf garden pea plant were closed with pure breeding tall garden pea. The resulting offspring were all tall. That is the question. Now, what I was trying to explain here, because these are the terms that you are going to come across: pure breeding, pure breeding, pure breeding, or true breeding. These are the terms that you're going to come across. So when you hear pure breeding and true breeding, it just means the same. Now, in terms of genes, in terms of the genotype, what is the genotype for pure breeding tall in this case and pure breeding dwarf? That is what I'm saying. Now, here is the thing. Dwarf, you know that is recessive, and tall, you know that is dominant. So in terms of genes, in terms of genotype, pure breeding, in this case for height, which is tall, I was saying we are going to use capital letter T. And for dwarf, we are going to use small letter t. Why are we using same letters? As you can see. Now, the first question is that what is meant by the term pure breeding? So what I said is that pure breeding refers to an organism whose both alleles are the same. Okay? Both alleles are the same, either dominant or recessive. So which means capital letter T in this case is dominant. So this is true breeding. Then for dwarf, TT is true breeding. Okay? If I'd used the D for dominant or for tall, which means the dwarf was going to be, in short, same letters in the genotype. That is true breeding. Same letters, it means both are capital letters or are small letters. That is what it means. Okay, I guess up to this point, we have no problem. I guess up to this point, we have no problem. Okay, now, question B. So for the question, since I was explaining when sound was not there, so for a second question here, that is Roman numeral 2, using your own letters or symbols, state the genotype of the parents. So genotype, you know that it's a genetic makeup of an organism. So what is the genotype for the parents? So for pure breeding dwarf is what? TT, small letter T. Then for pure breeding tall is what? Is capital letter T, because tallness is dominant over shortness in terms of height. Okay, in terms of inheritance of height is dominant. Okay, so now we can now move to question B. Using the genetic diagram, show the cross between the dwarf parents and one of the offspring. So this is where you gain a lot of marks here, using the genetic diagram. Show the cross between dwarf parents. Now, which one is a dwarf parent? We use T as the letter for dwarf parents here. So, dwarf parent are small letter T. And one of the offspring. Now, if you look at this one, they are saying here, the resulting offspring were all tall. Now, were they heterozygous tall or homozygous tall? If this capital letter T and small letter t were closed, you're going to find all the offspring are going to be T, 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 T. Okay? If you want, you can carry out a test close here and see. That is what it means. So which means we are closing the true breeding dwarf and the heterozygous offspring. So that is what we are crossing. So now let us look at how to put up the genetic diagram. So this is how you do it. So you're going to start by writing parent. So you write the phenotype first. parent phenotype. What was the parent phenotype? Phenotype, we said, is the outward expression. So parents were tall, and of course, what? Dwarf. Since we are crossing the heterozygous tall, and of course, the dwarf parent. So now, what about here? Now we are going to write parents what? Genotype. So we write now the genetic makeup of the parents. So this is tall, but expressed or written as this. Okay. Then this one is the T. So that is the genotype. Then now what happened? Let us write now the gametes. Okay. So for the gametes, we are going to put these in circles. So T. Then you separate them at least there's a distance here, and again this small letter T. Then here we are going to put a T, and of course again a T. Then now we do the crossing. So this with the first one, so we're going to have T. Then this one with the second one, we're going to have what? T. Then this one with the first one, we are going to have T. Then this one with the second one, we are going to have what? T. So this is the first filial generation or first offspring. So we can say first offspring pheno. So F1 phenotype. Okay. Then F1. Oh, this is genotype, please. F1 genotype. So these are F1 genotype. I'm not saying that you put the arrow like this, but you need to be in line with this. Then F1 phenotype. What will be F1 phenotype? You know that T is homozygous. I mean, T is recessive. So it will be shielded by this. The tallness will be expressed. So this is in terms of phenotype is tall. This one is tall. This one is the dwarf. This one is what? Dwarf. Okay. So now that is how we answer this question. So now what was using the genetic diagram showed the cross between dwarf parent and one of the offspring. Okay. So that is what we do. So the whole of this gives us what? 5 marks. And of course, I forgot here to put fertilization. So here you need to show that fertilization took place. And of course, here you put X. Okay. So that is how you draw the genetic diagram. Let us look at the last question on the same first question. That is C question. Differentiate between homozygous and heterozygous. So now, this is from the first part of genetics where we find these terms. Okay, from the first part where we find these terms, that is where you find, that is where this one is coming from. So what are the differences between homozygous and heterozygous? So we can say homozygous is a type of genotype. Okay, type of genotype where both alleles are the same. Okay, either dominant or recessive, whereas heterozygous is a type of genotype where the alleles are different. Okay, the alleles are different. So one is the dominant One is dominant, the other is recessive. So that is how we differentiate them. So this is the difference. So the difference between the heterozygous and homozygous is that homozygous type of genotype is where both alleles are the same, either dominant or recessive, whereas heterozygous, we are looking at the type of genotype where alleles are both different or are different. One is dominant, the other one is recessive. The example that we can give is, for example, here, the tallness can be capital letter T and small letter t. This is heterozygous. Okay, this is heterozygous. But for TT, capital letter T or small letter t, these are what? Homozygous. Okay, so we've fully answered the first question. I hope we can proceed to the second question. So please let me hear from you if you are able to follow clearly here. Are you able to follow? Okay. Marjorie is saying no sound. So please, can you confirm that you are able to get me? I'm not able to ascertain whether people are able to get. Are you able to get me up to this point? Is my voice, am I audible to your end so that we can continue? Clara is saying I'm late. No, you are not. Because this is just the first question that we are answering. Now, let me hear from you if you are able to get me clearly up to your end so that we can continue to the second or to the next question. Are you able to get me? Let me hear from you if you are able to get me. Okay, Precious is saying yes. Any problem up to this point? Are you following? Are you following up to this point? Okay, so let us go to the next question. So for the question that we've answered, please, you're going to find that most of the things will just keep on repeating the same things, especially the crossing thing. So the second question we are answering is state 1 sex linked disease. Okay, state 1 sex linked disease. Okay, at some point we are going to look at what is this sex linked. Maybe I can just explain it now so that even as we go on, it will be clear. Now, you know that humans have in the body, they have what? 46 chromosomes. Okay, 46 chromosomes, of which we have 23 pairs. Okay, 46 chromosome, 23 pairs. Now, the 23rd part or pair is a sex chromosome. Okay, the 23rd pair is the sex chromosome. So we have 23 pairs. So which means 46. We have, let's say, on top 1, 1, 1, 1, 1, 1, 1, 1. These are pairs. Pair number 1, pair number 2, pair number 3, pair number 4, up to 23. The 23rd pair or the pair number 23 is the sex determining, or is a sex chromosome. And now, in humans, or what determines, or the sex hormones that we have, I mean sex chromosome that we have, for male, we have X and Y, of which the X chromosome is longer than the Y because the X has a lot of genes compared to Y. Then for female is XX. Okay? Now, the sex-linked disease is normally, or it normally affect the X chromosome. So it's normally found on the chromosome X. So what we can say in other words, the sex-linked disease are the disease that are related with the X chromosome of the sex chromosome, or the disease that are linked to the sex chromosome. We are going to get into details even as we go on, because these are the things that we are going to look at as we go on. Okay, so now, okay, I'm following. Okay, yes. All right. So now let us answer the question. These I was just trying to explain just some things so that it makes sense as we look at this question. So state 1 sex-linked disease. So one of the sex-linked disease that we can talk of is green color blindness, or in this case, I'll put also hemophilia. Okay, so hemophilia is one of the sex-linked disease. Then also we have green color blindness. Okay, color blindness. So these are some of the what sex linked disease. So you can put hemophilia or red green color blindness. Then now the second question is that what is meant by sex linked characteristics? Okay, what is meant by sex linked characteristics? I think I explained a bit here. Okay, sex linked characteristics or disorders, one and the same here. So now what are these? Okay, so these are the characteristics linked to the sex chromosome. So characteristics, okay, characteristics linked to sex chromosome. Okay, so if you are asked of disorders that you can find, this is hemophilia, and of course red-green color blindness. So these are characteristics that are linked to sex chromosome. These are ones that we call sex-linked characteristics. Okay, or characteristics that are seen as a result of genes on the sex what chromosome. Okay, aside from the genes that are there in the sex chromosome, you have extra genes. Okay, those are linked to normally to the sex chromosome. So I forgot to mention that. Okay, we are going to look at that. In the body you have, we said the 23rd pair is sex chromosome. What about others or other hormones such other chromosome? 23 or 22 of them. 22 of them are called autosomal, as we are going to look at that. Now, using the genetic diagram and appropriate symbols, explain how a man with normal eyesight. Now, listen. These sex-linked characteristics, since I said they affect the X chromosome, okay? They are linked to the sex chromosome, but normally sits on the X chromosome, and they are recessive. Okay, they are recessive. That is one thing you should note. So now, a man is always affected. A normal man, a man is, or male are always, so let me say, males are never carriers. They are never carriers of the disease, which means they are either affected or normal. So they are never carriers, but ladies or female are carriers. Okay? Are carriers. So now, here they are saying using genetic diagram and appropriate symbols, explain how a man with normal eyesight. So a man with normal eyesight, you know that the X chromosome, the chromosome for a man, or the allele for male is X and Y. So a normal man, in this case, we are going to use, what symbol are we going to use? Red color blindness. Where is it? Eyesight. So since this is red green color blindness, let us use R for normal. So I'm going to put R here for normal. So this is the allele for what? And these are written, you write them as a superscript there on top. So I'm going to use R for normal allele. Okay? To a woman who is a carrier of the trait of color blindness. So a woman, you know that is X. So since she's a carrier, one is going to be normal, then the other one is going to be going to be a carrier. So this is how a carrier looks like in female, and this is how a normal man looks like. If we had a small r here, which means a man is affected, okay, has color blindness. So please, I've used R, that is the dominant, because these, you know that they are expressed in recessive form. So they are recessive. Sex-linked, they are recessive. So which means only when this recessive part is there, that is when one is affected. I guess you get that. Okay, so these are the genotype that we expect. Okay, so using the genetic diagram and appropriate symbols, explain how a man with normal eyesight married to a woman with carrier of the trait for the color blindness can have a child who is colorblind. So let us cross. So in this case, in crossing, we are going to say parents, as always, we are putting up the genetic diagram. Then we are going to write, this is parent phenotype, please. Phenotype. What is the phenotype for the parents? So a man is normal. So we're going to write normal male. Then now here we are going to write normal. You know that if a female is a carrier, it's also normal. So normal female. Okay, so we can put in brackets here carrier. So now, what about the parents genotype? The parents genotype, how is it going to be? So the parents genotype for a normal man, we said is X, and of course R, then Y. Then now for female or for woman who is a carrier, it's going to be X, R, then X, R. So please, you start with a dominant, okay? Or start with a normal one, normal allele here, the one that is not affected here. So then that one. Okay, so then now what will happen? We go for gametes now. Gametes. So for gametes, what did we say? We put this in circle. So we're going to have R, then we circle it. Then of course X, Y, there's Y. Or let me just bring it here since it will not fit there. So you can just start parents, parents, phenotype. We have normal male. Then we have normal female. Then we can say carrier. Okay. Then now we have parents genotype. Parents genotype. Now, what is the parents genotype here? We said XR, then Y. Then this one is XR, then XR. Okay, so what about now gametes? How is it going to be? So for gametes, we get this XR, then we put it, then Y, then here it will be XR, then it will be XR. So want to determine how what is the question? How they have a child who's colorblind. So let us close and see. So here we can start this, and that gives us XR, XR. This is the normal female, okay, because the chromosome are XX. I mean, here they are XX, okay. Then of course this one with that one, it will be XR, then XR. This is the normal female as well, but a carrier, okay, a carrier. Then this one goes with this one, it will be XRY. This is normal male. Then we are going to have this and that, which is XRY. This is the color blind male. So this is how they will have the color blind male. So this is the F1, or you can write offspring genotype. Then this is F1 phenotype. So this is how we draw the genetic diagram for the question. So this gives us what? 5 marks. Okay. So this one, have we answered the question fully? Yes, we've answered the question fully. So please, can you just confirm up to this point you have been following? Are you following up to this point? Are you following? Let me hear from you. Are you following up to this point? Someone is saying, what if I want to listen later? What can I do? Okay, so I guess the recording will remain on YouTube. So after the live session ends, the recording will remain, so you can still come back for it. Okay, so Clara is saying I'm following, Precious, I'm following. Okay. All right, so we can continue to the next question. And here is the next question that we are answering. So now, the table 5.0 below shows a cross between a brown male pig labeled B or pig B with two female pigs, brown pig A and white pig C. So here you have the male, and now you have two female. Okay, so let me just label this one male and two female. The first female is brown, the second one is white, the male is brown. So now after crossing, here as you can see offspring, after crossing, here for the, here in the case, so in the box for offspring, we have white and brown. But under male, there's nil, which means 0, no offspring, and here 0, no offspring. The question is, explain why pig B had no offspring. It's a male. Do male pig give a birth? No. So here we can look at male, that is pig B is male, so does not give a birth. So pig, because pig B is male and does not have a birth what? Canal. Okay, does not give birth. It's a male. So that is what we can say here. Okay. Then now, from the results in table 5.0, which means the results here, using the symbol B for dominant allele, so using the symbol B for dominant allele and B for recessive, small letter b. So this is the dominant. This is what? Recessive. These are the symbols that they've given. Here they've not told us to use our own, like in the first case. But here we are given the symbol. So pay attention to the details. Using the symbols B for dominant allele and B for recessive allele, identify the recessive phenotype of the skin color for the pigs. Identify the recessive phenotype of the skin color of the pigs. Okay, using identify the phenotype of the skin color for the pigs. What is the phenotype for the skin color for the pigs? Okay, so we have, do we have anything missing here? Using the determine the recessive before, identify the recessive phenotype for the skin color of the recessive. Okay, the keyword here is recessive. So which one is the recessive of these? So the one that is recessive is a white color. Okay, the white color is recessive. And of course, the reason, look at this. Okay, we are going to see. So look at the offspring 8, the brown 8. So this one is just the same as 1-to-1 ratio. So just look at it as 1-to-1 ratio. This can only be possible if it is closed with the dominant is crossed with a recessive. Is it that? No. The heterozygous, I mean. Anyway, let me not go to that. So this is the one that is, so the white color is the one that is recessive. Then suggest the genotype of pig A and C. So pig A and C, what are the genotype? So since we are saying the recessive is white, so which means white female is the genotype for white pig A. So we are going to say pig A, the genotype, and pig C. So for pig C, we are sure that this one is what? Is a white. And we said for recessive is small letter b. So they are saying, and here we said the recessive phenotype is white. Here they are asking us suggest the genotype for pig A and C. We know that pig C is recessive, and therefore the genotype is B. B. So this is the genotype. What about pig A? Now, pig A, if you look at it, in terms of ratios of offspring is 1 to 3. Okay? So this one can only be possible if this is heterozygous. So this one is what? B and B. So that is the genotype for this. Okay? Using the genetic diagram, show the results of cross between B with pig C. So B with pig what? C. So which means what you are crossing here is one, a recessive one, which is the, since you know that pig C is equals to what? B. The only thing that is remaining is for you to know the genotype of pig what? Pig B. Now, what is the genotype of pig B? Okay, so if this one is crossed with this one, it gave us this one, which is 1 to 3, which means also this one is what? Is heterozygous. We can perform a simple test here. So we are saying pig B is B. Then pig A, because we want to determine the ratio here, pig B also is pig A is also B. If you cross, it's going to give you what? B. You cross there, it is going to give you what? B. You cross here, it will give you what? B. You cross this one, is going to give you what? B. You've seen one white. This is heterozygous brown, heterozygous brown. So 3 brown. So which means the possible genotype for B is also B. So we are going to cross B and B. Okay, heterozygous and homozygous. So now this is question C. So we are saying parents. Okay, parents, we have pig B and pig what? Pig C are the parents. Then phenotype. What is the phenotype? The phenotype, we have brown and we have what? White. That is the phenotype. Then now what about the genotype? The genotype, we have B, then B. Gametes, we are going to have what? B, then B. Then we cross now. Fertilization take place now. We are going to have B. We are going to have what? B. We are going to have what? B. We are going to have what? B. This is 50-50, 1 to 1. Look at how many, if we were to look at, okay, let me just put this one, fertilization. So fertilization. Then here I'll put F1 genotype. Then F1 phenotype. So this will be brown. This will be brown. This will be what? This will be white. This will be white. So which means the chances are 50, 50. And if you look at this one, this is 50-50, 8-8, 50-50. So that is the correct cross that we can carry out there. So using the genetic diagram, show the results of the crossing between pig B with C. So that is how we cross it. Okay. So this answers question 3. So we are on to the third question. Do we have a problem up to this point? Let me check. I'm checking the comments right now, tending to see if there's someone who is not getting me clearly. Are you able to get me clearly? Please, can you just confirm that you are able to get me clearly? Just confirm you're able to get me clearly so that we can proceed with the next question. Can you proceed? Can we proceed to the next question? Now, what I would do is that since we've answered quite a number of questions, so similar questions, some of the questions I'll be skipping them so that we can manage to answer some different questions and like just going to the same thing. So let us see the second, the question that we are answering on number 4. So this is a different question that we need also to answer, okay? So this one is on family trees, that is pedigree. So let us look at how we can answer the question on families, okay, or pedigree. So also we are looking at the inheritance of the inheritance here, okay? Okay, so what is the question? So the question is, figure 5.1 below shows the pedigree diagram for two families, A and B, outlining the inheritance of sex-linked disease called hemophilia. So here also we are dealing with a sex-linked disease called hemophilia. Okay, so from the figure 5.1, which family has the parent who is a carrier for hemophilia? Now, before you answer this question, it's very important that you look at the key. What key is given here? So the key that is given is this one. So if you see a circle which is not shaded, just know that is normal female. When you see a box that is not shaded, just know that is the normal male. When you see the one that is shaded, just know that that is the hemophilic female. Then the box that is shaded, just know that is hemophilic what? A male. So what we are seeing here from the first family here, or family A, this is the marriage line. This is the marriage line. So these two people got married. This is a male and this is a what? A female. So they got married and of course produced these children. Okay, produced 4 of the children, of which one female was just a normal one male was just a normal one, and another female was normal one. But one male was what? Was affected. He had hemophilia. Okay? He had hemophilia. Now, what I said is that male are never the carrier. Okay? So hemophilia is H. We are going to use H for hemophilia. If we are not told which letters to use, are we told? I'm sure we are told. Okay. So male are never carriers because they only have X chromosome, and we said it is found on the X chromosome. So male are never carrier, but female can be carrier since they have 2. So if you can have the recessive one here and of course the dominant. So male are never carrier, but female are the what? The carrier. So here what you expect that the male here, in terms of parent, this one is never affected. It's just a normal one. but this one is the what? A carrier. In the case in the family, the offspring produced was affected. So the possible carrier or the carrier is this one. This one is just normal. So I thought of explaining that so that you know that part. But in this family, there's none. So which means in this family, no one has what? Everyone is normal. So this is normal. And also this one is what? Normal. Okay. So now the question from here is that, that is A1. From figure 1 point, that is 5.1, which family has a parent who is a carrier for hemophilia? So here you can see is family what? Family A. Give a reason for your answer in above, because in family A, there was a child who is what? Who is hemophilic. Okay, so because it produced or they produce one child who is hemophilic, because family A produced a child who is hemophilic. Okay, hemophilic. That is the reason why we are saying that is the family that contain a carrier, because they produce a child that was hemophilic. In this one, there's none, as you can see from the key. Then now, the other question is that give a reason for your answer, or just given the answer, because family A produced a child who is hemophilic. Using the symbol X and X, that is X to the power, X superscript here, capital H and small h. State the genotype of offspring H and J. Now, X, H, it means normal, okay? Then XH, here if it's in female, so if this is the genotype for female, X, then XH, this one is a carrier because of this one. We said sex-linked are recessive, so you're looking at this one. But XH in male, this is normal, then X, small letter h, there's nothing like carrier in male, so this one is the hemophilic. Okay, so now they are saying using the symbol of this, state the genotype for offspring J, H and J. Where is H? H is this one, then J is this one. So now, what are the symbols for H and J, or genotype for H and J? So now listen very carefully. This is a male. So if it's affected, then the genotype is exactly this one. So H, small h, and of course Y, because we said small h is hemophilic. So there's nothing like this one is a carrier, no? So that is what you should know. Then now, what about for J? J is a female. Now, a female, normal female is X, H, X, H. So the carrier is also a normal. Okay, so this is one possible genotype, but also this one, H, then X, H. Okay, but since we said this one did not have a carrier, so which means J, it is this one. Okay, but know that even this one is normal. A carrier female is also normal, because only one is affected, but the other one is just okay. Okay, so here we can put the first one, which is X, H, then Y. Okay, that is for, you can say this is for H. Then for J is X, H, X, H. Okay, then using the genetic diagram, show whether the offspring would be hemophilic or normal when H and J are crossed. So if we cross these, what will be the resulting what? Children. Okay, what will be the resulting what? Children. So now if we go with this, so also there are two possible. We can cross this and this, or this and this. Okay, So now, let us cross, so we can say in writing the genetic diagram, we can start parents. So parents, we had parent H and parent what? J. What are their, what are their genotype? What are their genotype? So genotype, we have, the genotype that we have X, H, that is for the one that is affected, then 1. Then of course we have X, H, and of course X, H, something like this. Okay. Then now, what about the phenotype? By the way, is hemophilic and carrier or normal. So here parents, then we say parents phenotype. Parents phenotype. What was the parents phenotype? So this one is the hemophilic. Then of course the other one we say normal. Okay, like I said, you can also put carrier is also the possible, but there we determine that there's no carrier. So what about the genotype? So the genotype will be X, H, Y, then also X, H, X, H. Okay. Then now, if we're to look at them now in terms of gametes, okay, so gametes will be X, H, then Y. Then here will be X, H, then X, H. Then now, if we're to cross this, so here you show that you're crossing, so this one's going to be H, X, H. Then this and that. So please take note, even as I cross, I might make some mistake, it's possible. Then H. Then this and that, it's going to be X, H, Y. Then this and that, it's going to be what? X, H, and Y. Y. Okay, what was the question? X, H. So this one, this is the F1 genotype. And of course, what about F1 phenotype? So F1 phenotype, this one will be carrier. Okay, carrier female. This one will be carrier female as well. Then this one will be normal male. And also this one will be normal male. Okay, that is if we had used this as the genotype. But if you had used H, that is the carrier for, if we had used for female X, H, and X, H, we're going to find that we have some, I think we're going to have some male that are affected. So what is the question? Using the genetic diagram, show whether the offspring would be hemophilic or normal when H and D are crossed. So here the offspring will be what? Will be normal. Only carriers, but they will be normal. Okay, unless if you had used this one as a genotype, of which, why we are trying to avoid that, because in the first one, from the diagram, which family has the parent who is a carrier for hemophilic? So if none of the parent here is a carrier, then how can we find someone who is a carrier here? Okay, so which means this one this one, I mean, this one itself, since we've picked this one as a carrier, which means this one is normal, okay? That is the reason why I've gone with that kind of answer, okay? So now let us look at the other one. This one is just the same as the B and Shan alleles, is just the same. But let us look at maybe something different. Perhaps we look at something for blood group. Something for blood group, I guess it's going to help us to learn something as well. So please, I've explained quite a number of things. I don't know if you've been following up to this point. Have you been following up to this point? Can you just confirm that you have been so Patricia Mlenga is saying J is just a carrier. Okay, let me go back. So Patricia is saying J is just a carrier. Now, Patricia, if J is a carrier, where is this? Where is because if you have here, let's say this one was a carrier. Okay, let's say this one was a carrier. We're going to have the situation like this, but here none of that. Okay, if we are to cross, because I said male are normally not carriers, so which means this one automatically is just normal. Now, if this one is a carrier, where is this one getting the hemophilic or hemophilia that the person is carrying? Because here, if we are going to put that, okay, let's say this one is a carrier, X and H, we're going to have this situation here where we have one of them being what? Hemophilic. And of course, others are going to be carriers. But here, if I look at this family, there's no carrier here because the resulting here, how many are they? Okay. So we have 3 boys. All of them are just normal. Then one who is a carrier. Hey. Okay. Anyway, let me not go into that. But that is my explanation on this one. Because even if we were to put, okay, let's say this one is affected. Then, of course, surely one of the boys was going to be. Okay. So try to reason on that or in that line. And of course, we can argue or we can debate on that part. So look at it in that way. Okay, so let us look at the one for blood group. I'm interested in the one for blood group because we've done quite a number on just mere crossings. Let us look at the one for blood group. So here is the question now. Mrs. Mumba delivered a child. Okay, Mrs. Mumba delivered a child or a baby girl in a certain hospital. Mrs. Mumba had a blood group O and the father to the child has a blood group AB. Now, the blood group, these are called multiple alleles. They are controlled by different alleles. So blood group O is recessive. So blood group O automatically, the genotype is this one. Then the blood group AB, it is A and what? B, because blood group A is dominant over O and blood group B is dominant over O. But when you find A and B, they are both expressed and therefore one has blood group AB. So these are the genotype from this marriage. Now, the father to the child has a blood group AB. Mrs. Mumba sues the hospital for giving her a wrong baby whose blood group was O. Explain using the genetic diagram why Mrs. Mumba would win the case. So Mrs. Mumba, because the husband is blood group AB, she sues the hospital. Now, if we are to do the crossing here, what is the chance that Mrs. Mumba is going to win? To show that Mrs. Mumba is going to win, after crossing, no child should be found with blood group O. In that case, she'll win the case. But if one child is found with blood group O, there's a chance of blood group O, then she will lose the case. Now let us see. Since we are told using genetic diagram, so in this case we are going to put parents. Okay, parents here we are going to put Mrs. Mumba. Then of course we have what? Well, let me start with Mr. Mumba. Okay, Mr. Mumba. Then here we have Mrs. Mumba. These are the parents that we have. Then now, what is the phenotype? Let me say parents. Parents phenotype. So parent phenotype, we have blood group O, and this one is blood group what? B. What about now the parents genotype? Okay, parents genotype. What is the genotype for a parent? So the genotype for a parent is blood group O is this. Mr. Mumba is, I've swapped this. Okay, so Mr. Mumba is the one that's supposed to, Mrs. Mumba. So Mr. Mumba is B. Then this is O. Okay, so what is the genotype of Mr. Mumba? AB. Okay, the girl, the father to the child, and okay. So AB, not B. AB. So we're going to say A. That is the genotype. Then B. Then for this one, it's going to be O. O, blood group OO. Okay, these are the alleles that you find. Then of course now, what about gametes? So we are going to have A. Then we are going to have what? B. Then we are going to have what? O. Then we are going to have what? Just try to reduce the size of this. Then we are going to have this. Now here, fertilization. So the chance is that this one is going to be A, O. This one is going to be A, O. Then this one is going to be B, O. This one is going to be what? B, O. So this is the genotype, F1 genotype. So the first or the offspring will have the genotype or this genotype. Then of course F1 phenotype. What will be the F1 phenotype? The chances, this one will be blood group A. This is still blood group A. Remember what I said, blood group A is dominant over O. So where there's O and A, the O is not expressed. Okay, it's shielded. Then this one is blood group what? Blood group B. Then this one is blood group B. So the only chance that is there that Mrs. Mumba could have blood group, child with blood group A and blood group what? Blood group B. Okay, so could have this one, please, goes with that one A. This one goes with that one A. Okay, this one with that one. I guess I've done the proper crossing here. So the only possible is blood group A and blood group B. That is the child. Okay. So now the question is, what is the question? So Mrs. Mumba would win the case. Look at the blood groups that are here. So none is blood group O. So I should claim that none of my child should be blood group O. Looking at the father's blood group. Okay. Then what could have been the correct genotype of the actual father? Okay. In the case Mrs. Mumba had maybe some extra affairs. If that was the child to Mrs. Mumba, what would be the blood group to the father? So the blood group to the father, since she's blood group, the child is blood group O, the blood group to the father could be blood group O or blood group what? blood group B, okay, or perhaps blood group A. Or if you cross these with blood group O, you're going to find um, that one of the offspring could be blood group O, because blood group O is only expressed when it's OO. Okay, so where O is appearing, if there's a letter, capital letter, just know that it is not expressed as blood group O. Okay, so that is these are the possible ones. So these are the possible genotype to the actual father, okay, of the child. So in the case, let me say, in the case, I think I've some misleading there. In the case where now they want to determine this case, Mrs. Mumba has won that, yes, this is not my child. Now, what would be the possible father to the child? So this could be the possible father to the what? To the child. Okay. I guess you get that point. Okay, so the genotype that we have is this one, and of course that one answers the other question. So now let us see the other question. Okay, so we have another interesting question that is on pedigree. Let me hear from you if there's any problem up to this point. It has been almost an hour of revision. Are you following up to this point, or people have fallen out? Are you able to get a thing? Okay, so let us answer. Let me see if there's a different question that we can answer. Show the genotype of the offspring. Briefly explain the risk of a girl having multiple defined sex-linked characteristics. State the number of chromosomes in nucleus of homophilic. Okay, so let us answer this question. I think could be the last one, so that we can arrange some other time maybe to meet, or I'll do the recording for the whole thing. So this question that we are answering now, that is figure 5.0. Figure 5.0 shows the inheritance of red-green color blindness. Red-green color blindness. Okay. In generation of two families. In generation of two families. So now, which are the families that we have? So we have family Z and family what? We have family Z and family Y. The first question is, so as you can see the guide, so the guide, even from the previous one, the shaded one, it means that they are affected, okay? Then, of course, the unshaded one, they are normal, but you know that the rectangle or the square here represent the male, and of course, the circles represent the female, okay? So now, which letter in figure 5.0 correspond to the second filial generation of offspring? So this is the family. So we have this family, first family, they got married, and of course they produced the child or the children. This is called F1, the first offspring or generation F1. Then now, after now, one of the child from the first generation, and of course from here also, these parents, this is the marriage line, they got married and of course produced these children. So these are F1. So now from the F1, now if they got married, one from this family, you know this one is coming from a different family. So a girl from this family got married to a man from this family got married to this one. And of course they produced the children. So this is what we call F2. Okay, so which letter correspond to the second filial generation of offspring? So in this case, we can put letter L or M, represent second filial generation. Using the symbol XR and XR, okay, capital letter and small r, determine the allele for the red color blindness and for the normal site of the pedigree diagram. So now we are determining the what? The allele for the what? For the color blindness. Okay. So now this is in both male and female. So in male, in female, in male we said they are never carriers. So for red color blindness in male is X, R, then Y. Okay. But in what? In female, it has to be both small r. So X, R, X, R. So which means someone is colorblind. If it's just X, R, then X, R, or X, R, then X, R. This one doesn't mean that someone is colorblind. This is a carrier. So in male, in female, this is a carrier. An affected one is this one. So take note of this. So these are the what? These are the ones that we expect here. Then for normal, in female is XR, XR, or XR, then XR. A carrier is also normal. That is in what? Female. Okay, so I can say in female. Then in male is only XRH. I mean XR, big R. Why am I put H? So why? Okay, so these are the ones. Then predict the genotype of offspring J and K. Where is J? So J is right here. I mean, K is right here. Then J is right here. Now, if this is sick, if this one is affected by hemophilia, which means this J is a carrier, then this one is completely affected. So for J, is going to be a carrier, R, then X, R. But for K, is a male. Male never carriers. So R. And of course, remember these these are recessive. So these are the genotype. Then of course, what is the other one? Using the genetic diagram, J and K. J and K. So carrier and the one who is sick. Let us cross them. So we're going to start with parents. So they say parents. We have here father. We have here mother. Okay. So in terms of phenotype, what did we say? Mother is carrier, father is sick. So we're going to say color blind or color blindness. That is the father. Then this one, what? We are going to say carrier. Okay. Then now, what about the genotype? What about the genotype? So for the genotype, we are going to put X. That is for the father who is sick, X, Y. Then this one is going to be X, R, then X, R. Then now for gametes, we're going to put X, R, then Y, then this one X, R, then this is X, R. Okay, then we cross now. So we're going to have X. So we start with big R, then X, R. Then this one is going to be X, R, X, R. Then this one is going to be X, R, Y. Then this one is going to be X, R, Y. So now this one is carrier female. This one is what? Colorblind female. This one is the normal male. This one is what? Color blind male. Okay. Then now, this is the phenotype, F1 phenotype. This is the F1 genotype. So F is capital letter, please. So F1. So now this is the fertilization. You can put fertilization here. Okay. So that is how you draw the diagram. Okay. So thank you very much up to Thank you very much for being with me up to this point. I thought we are going to cover as many questions as we can. I guess I'll put the other information into the recording. So please make sure that you invite some more of the colleagues to this channel. I think we are going to be revising from time to time. The next one, I think we are going to have some mathematics. So let us revise also mathematics. Let us look at also other subjects. It doesn't just end to those who are writing, but also those that are writing in November. Those that have exams, it might be from outside the country, that is outside Zambia. I think in terms of learning, we just have the same thing. So let us continue revising. Let us continue inviting some more to join this platform. So the subjects that we expect on this platform, we have mathematics, have physics, biology, chemistry, and also additional mathematics, where you are whether you are doing, in the case you are in Zambia, you're doing pure sciences, we do all those. And also, if you're interested to do, you are from outside, you are doing Cambridge, you are from Zambia, you are outside doing Cambridge, we also offer IGCS, that is IGC CSE, and also we also do advanced learning, that is A level. So in those categories also, you are free to will be able to post such materials. And of course, if you have some challenging questions, make sure to post them in the comment section. If I have time, I'll be able to handle the questions, just like I've done in the recent past. I've had time to at least to create some recording on the requested topics. So let us grow this platform, and of course, let us continue next time.